Solving systems of linear equations with tables and graphs. A system of linear equations is a set of two or more linear equations. The solution to a set of linear equations is the ordered pair that satisfies both equations at the same time. Let's look at a couple of examples. In example 1, we have two equations in this system. Our first equation is y equals 2x plus 5, and our second equation is y equals negative 3x. So when we look at this, we're ultimately trying to find the solution, which the solution is the ordered pair that makes both equations true at the same time. Ordered pair that makes both true at the same time. Now on a graph, that ordered pair is the point of intersection between our two lines. So our red line right here is y equals 2x plus 5, and our blue line is y equals negative 3x. So if we plot both lines on the same coordinate grid, the point of intersection is our solution. So the ordered pair negative 1, 3 makes both of these equations true. And we can test that out by plugging in that ordered pair to each equation. So let's try the first one first. Y equals 2x plus 5. So let's plug in 3 for y, and let's plug in negative 1 for 2. So we see that 2 times negative 1 is negative 2 plus 5. 3 equals 3. That's true. We also can check to see if negative 1, 3 makes our second equation true. So let's plug in 3 for y and negative 1 for x. And we see that negative 3 times negative 1 is equal to 3. So 3 equals 3. That checks out. So this ordered pair negative 1, 3 is the point of intersection. It's our solution. It's the ordered pair that makes both equations true. We can also look for our solution to a system of linear equations in a table. So here I have listed 5 different x values and then the y values that correspond with each equation. So this middle column right here are my y values for the equation y equals 2x plus 5. And my blue column, or my last column right here, are my y values for y equals negative 3x. So what I want to try to find is which x value has the same y values for both equations. So starting at negative 2, our red line has an output of 1, and our blue line has an output of 6. So that would not be the solution. But here we can see that when I plug in negative 1 for my x, I get 3 as an output for 2x plus 5, and I get 3 as an output for negative 3x. So on a graph, my solution to the system of equations is the point of intersection between the two lines. In a table, it's where I have the same output for a particular input. Let's look at one more example together. In example 2, we have two equations in our system, y equals negative 1/4 x plus 8, and y equals 4x plus 9. So again, looking at the graph, we've graphed both equations on the same set of axes. So our red line is y equals negative 1/4 x plus 8, and our blue line is y equals 4x minus 9. And I can see that my solution, or the ordered pair that makes both equations true, happens at this point of intersection. So my solution would be 4, 7. Again, I could plug in 4 for each of my x values in these two equations, and I would get 7 as my output because 4, 7 makes both of these equations true. I can also look for this solution in my table. So in my table, I want to look to see which input has the same outputs for both lines. And I can see that that happens all the way down here. When my input is 4, my output is 7 for both equations, which tells me that my final answer, or my ordered pair that makes both equations true, is the ordered pair 4, 7.